In general, extra heavy opportunity crudes contain up to 50% residuum content, compared to only 10% residuum content in conventional light, sweet crudes, with the molecular composition of the residuum content varying significantly among heavy crudes. Refiners have had mixed experiences with certain types of crudes increasing the carryover of asphaltenes to the DAO. Murphy Oil processes a variety of crudes and has observed differing yields of D-asphalter bottoms. The company has not correlated an increase in carryover with a particular type of crude. Ultramar Diamond Shamrock has experienced carryovers of 400 to 600 ppm of asphaltenes to DAO, which they have attributed Venezuelan crude fouling feed filters in the downstream hydrotreater. KBR found that specific crudes, which include Minas, Robbie, Dutch Incorporated, Zerzatine, and Santa Barbara, have a propensity for asphaltene carryover, and that operational adjustments, such as changing the solvent-to-feed ratio, raising the resid cut point, raising the extraction temperature, and cycling a portion of the asphaltenes back to the extractor, can lessen asphaltene carryover. Hydrogen sulfide from vacuum residue feed and makeup solvent may accumulate in the circulating solvent. The accumulation of hydrogen sulfide can corrode equipment, lower solvent strength, and necessitate lower temperatures and higher pressures to achieve the desired performance. Operation of the vacuum tower impacts hydrogen sulfide levels in the circulating solvent because hydrogen sulfide can enter the unit dissolved in the vacuum feed when processing feed with very sour feedstocks. Ensuring the vent valves are open to allow suitable purging from the plant is considered to be a sufficient control mechanism. Purging a portion of the solvent, such as from the solvent drum in the recovery section, can control hydrogen sulfide levels. Treating a slipstream of solvent can be done with caustic or amine if a prohibitive amount of solvent were to be purged. The question of which types of indicators work well with asphaltene separators was raised at a past American fuel and petrochemical manufacturers Q&A session. One representative said that indicators and controllers based on a ball float mechanism have an established history of successful use in this application, and that these indicators are backed up by a series of tri-cock nozzles and valves arranged vertically on the side of the vessel to span the expected range of the fluid level. Another attendee reported the successful use of a differential pressure gauge with one tap at the bottom of the tower and the other above the expected level of the fluid, with the taps fitted with oil purges to prevent plugging. A third attendee said that switching from a ball float to a transducer indicator made it easier to make level measurements in the strippers of the flash tower.